Hello, everyone, and welcome back to Learning with Jelly. So, today is going to be our fifth video in our Python for Fundamentals series that is meant for you to have some foundations before we go into things like data cleaning, machine learning models, and other concepts within data analytics and data science. And one of the most popular libraries that you will utilize every day is going to be this library called NumPy. So today we're going to go over Numpy, which is numerical Python. Why is it important in data science or data analytics, and how can you use it? All right, so let's go ahead and get started. So our objectives today is the NumPy library. Why should you care? No, really, you should care. You're going to use this library a ton. What is NumPy and why arrays? So we've talked about strings, we've talked about lists, we've talked about dictionaries, but now we're going to talk about a new Python object today of arrays. You're going to learn how to manipulate arrays and pretty much embrace the array. Okay. Many Python libraries are built off of NumPy. And so you really should have a good understanding of what this library can do in things that you can perform for data analytics and for data science concepts. So, how does it show up in data science or data analytics? Okay. It is used for basic math all the way up to image classification and everything in between. It can be used to explore your model features. So, we're going to talk about how we can get correlations among predictors that are highly correlated with one another. We're going to have to account for things of that nature. And it is the foundation for matrices. And a lot of machine learning models have matrix multiplication or matrix factorization in the background. From recommendation systems, AKA, how does Netflix know what to recommend to you? And this is a nice visual of that, all the way up to reducing dimensions for principal component analysis, and so forth and so forth. So, NumPy is used either subconsciously or consciously and a lot of your data analytics exploration, data cleaning, as well as the machine learning models that you're going to encounter. Okay. So, what is it? Short and sweet, it's a powerful mathematical Python library. Okay. It is used for working with arrays, and you also can utilize it to create random data distributions as well, which is useful in academic settings or in generating dummy data. So, what is an array? Okay. So, an array is very different than a list, and we're going to see the differences momentarily. But an array is a Python object that contains a grid of values. Each array contains one data type. So, I can have an array of integers. Okay. So for instance, if I'm working with a data set, I can have the column of age. And within this column, I can have a whole bunch of integers, right? And so the column age itself is going to be an array of integers. Okay. I also can have an array, all right, that's going to be something like car color, for instance. In every value in car color is going to be of an object or of a string. Okay. So an array can only contain one data type, all floats, all integers, all strings. It can be a one-dimensional array up to several dimensions. And because it contains this one data type, it is faster than lists. Okay. And you're going to be able to manipulate arrays, which then is going to be the foundation of how we create data frames. Okay. Because eventually we want our data in this data frame object type, which you're going to see in the next video. So, what do I want you to know? NumPy, mathematical Python. Okay. You can do things from mean, median, standard deviations, correlations, addition, multiplication, etc., all the way up to matrix multiplication and matrix factorization, which is going to be in a lot of machine learning models. The basis for NumPy is this data object, this Python object called arrays. And you also can create random data distributions with NumPy as well. What makes an array different than a list is that it can only contain one data type, where list can contain multiple data types, and it's going to be faster than lists. Okay, so let's continue on. So the library and those arrays, let's work with it. So you want to import numpy as np. Np is just an alias, so I don't have to keep typing numpy over and over and over again. But in order to get the features and the functionality of numpy, you must import the library. Okay. And then once we import that library, we can start building our arrays. So I have np.array, right? And inside my parentheses, I have what I want my array to be: 4, 5, and 6. Okay. Notice the brackets around the array inside the parentheses. That's very important. And so now I'm just going to figure out if my array is actually an array. So when I run this cell, it tells me that the type of my array is that it is an array object. Okay. Knowing what type your objects are is going to tell you what you can do. You can't do the same thing to a string as you can do an integer. Similarly, you can't do the same thing to a list as you can an array. Okay, so that is my array. But why should we use them? So let's revisit list again. So I have this list one, which is 1, 2, 3, and I'm trying to add 2 to list one. Okay, so pretty much I want to turn this into, and let's go ahead and get out our drawing tool. If I add 2, what I want is for this to be 3, 4, and 5, right? That's what I want to change this list to. So let's see if we get what we want when we run this block of code. Instead of adding 2 to every element in the list, only thing that it did was add 2 to the end of the list. And that's not what I want. Okay. So in order to add things together, right, where I can get this 3, 4, 5 out, I need to have an array. Lists do not have that type of functionality. This is more of concatenation, where it's going to put it side by side, but it's not going to actually perform math on each element. Okay, so I get the mathematical library uploaded, which is NumPy, and now I have an array. Okay, so I'm using the same thing. Instead of I have numpy.array, I'm passing in that list, and then I'm going to add 2 to that array. Okay, so let's see if it works. And in fact, it did. It gave me 3, 4, 5. So arrays is going to add that layer of mathematical functionality that list alone will not be able to do. Okay. All right. So what else can we do outside of math? We can get the shape of an array. So in this case, I have one dimensional array, and then I have another dimension that I'm passing through, or another list, better yet. So I want 1, 2, 3, and then I want 10, 11, 12. Notice the extra brackets around that. Okay, so when I am listing more than one list in np.array, I need another set of brackets surrounding it. And now I'm going to get the shape out. Okay, and so this says that is 2 rows, 3 columns, right? So let me just print out the array so we can see how it looks. So this is what it looks. It stacks the 2 on top of each other, right? I have 2 rows and I have 3 columns. All right. So this is how the array looks. I can reshape it. So say for instance, I don't want 2 rows and 3 columns. I want 3 rows and 2 columns. And it's going to give me that. Okay, where it's 3 rows and 2 columns. And outside of reshaping arrays and things of that nature, I can generate random numbers. So from the NumPy library, I can import random, okay, the module random, and it's going to allow me to generate random numbers. So in this case, I wanted to generate random integers, okay, random integers from 0 to 100, and I wanted to return 10 of those integers, okay? So when I run this, I get 10 random integers from 0 to 100. Okay. I can also generate random distributions. And in this example, we're going to generate a random normal distribution. So statistics is the foundation for machine learning. So we're definitely going to talk about statistics down the road. But it's good to know that NumPy can also generate these random distributions for us, okay? So loc is just the mean, the scale is the standard deviation, and I can run a size in there as well, okay? So I'm saying random dot normal, passing the mean, passing in the standard deviation, and then I get the distribution out. Well, the array, right, is 3 by 3. So I have 3 rows, 3 columns. And now let's say I want to plot that random normal distribution, okay? So I'm going to import a plotting tool. In this case, I'm using Seaborn, which you're going to learn about in another video. And I'm passing in that variable, random normal dist. And what I get out is my normal distribution. Okay, this is just telling me to update to a different version of this plot. Okay, so we see that NumPy not only can do multiplication, addition, things like that on arrays, it can reshape arrays, right? And it can also generate random numbers as well as random distributions that can help us look at the distribution of our data, right? Okay, so that is the overall concept of NumPy. It's numerical Python. Is used for mathematical operations. Is used way more than lists because it's going to compute faster and it's going to store one data type, which is what we need for our data frames going forward so that we can run models on. So if you want to follow along, I'm going to have a link to the GitHub where you can pull down this notebook and kind of play around with NumPy as well. But please like, comment, and subscribe, and I'm going to see you in the next video. Bye-bye.